Okay, today we're going to go over some terminology for statistics and start with some words that describe shape. A while ago we talked about describing a distribution with our SOCs, S-O-C-S, so shape, center, spread, and outliers. So right now we're just focusing on shape. So we have seen so far we could have something with a uniform distribution, that looks something like this. It has sort of a rectangular shape where there's an equal number of each item in each category, and it's just kind of rectangular, and we saw that with the birth month when we looked at the data about babies being born in a certain month with a certain weight and a certain mother's age. So we could have a uniform distribution. We could have a normal distribution. So that's your kind of symmetric bell-shaped curve, and you will see this a lot in statistics, symmetric, bell-shaped, and this normal distribution has a lot of properties that are interesting and useful, and we will see those. So you might have something with a normal distribution, so a lot of them in the middle, and it's symmetric like that. That's supposed to be perfectly symmetric. And then you might have something that's skewed left, and think of this as a tail on the left. So your extreme values are on the left. Tail on the left. So that would look like this. There's your tail. Something like that. And you can have skewed right, which means the tail is on the right. Extreme values are to the right. So that would look something like this. That way. So that's just for shape. And now we're going to move on to a different set of terminology for statistics in general. So there are 4 words. There are 5 actually. These two tie closely together: population and parameters. So the population, these are really important definitions. Population, what does that mean? So the population is the entire group you're studying and trying to draw conclusions about. It is the entire group. It might be the population of the United States, the entire group you are studying. It might be all the animals in a zoo. The entire group you are studying, and you're trying to figure out something about your population. So let's just say, for example, the population is this classroom, the students in this classroom, the entire group you're studying. Then a parameter is some kind of numerical summary about the population. Numerical summary, like, when I say numerical summary, I mean like the mean or standard deviation. Could be the mode, mean, standard deviation, about the population. So it might be the mean number of hours of sleep that everyone got last night. Numerical summary about the population. So these two words, population and parameters, go together, and this is, the parameter is measuring something about the population. Those go together. Okay, and now there's a kind of side word here called census, and that is if you can measure every member of the population, you're taking a census. And there's one that happens in the US, I believe every 10 years, measuring every member of the population. But to do that, it's very costly and time consuming, so we can't always measure every member of the population. So what we do in statistics is we take a sample. So sample out of the population. So a sample is a portion of the population. And using that sample, we calculate something called a statistic. Statistic from the sample, and that's a numerical summary about the sample. Numerical summary about the sample, like mean or standard deviation about sample. So I'll write here just so it looks parallel here, mean, like the mean or standard deviation, except it's about the sample, so it's called a statistic instead. And at some point you're going to use statistics to figure things out about your population.